Hello. I saw Armin's title when he submitted it, and I was like, well, I got to come up with some quippy, goofy one too. I'm going to explain a little bit about where this comes from momentarily, but I also have to acknowledge my co-authors or collaborators here, Jeff Raisler and Art Schmidt. Those two really did a lot of groundwork development on this course, and then I kind of swooped in at the end, and I'm taking a lot of the credit. Objectives. I'm going to talk about some of the outcomes for this project-based course. This is now going one step earlier in the curriculum, so I'm going all the way down to our first year. So when we start thinking about open-ended, first-year type courses, it is possible to do some project-based learning. And so this course is 100% dedicated to the project. And so we're going to outline all the primary purposes and then also talk about scaffolding. So I'm glad that Armin already kind of defined what scaffolding is. Here's my context. So this is required for all civil and environmental engineering students, so it's not actually a concrete focused class. So this has all of our students in it, which, about 85 to 95% of those are going to be first year, first semester freshmen. And then we also throw in all of our transfer students who might be transferring from somewhere else in the college, somewhere else in the country, from wherever. And then we just get a smattering of, well, I didn't take it my freshman year for some odd reason. And so then we get a little bit of a mixture, but it is mostly these freshmen. So my enrollment in this class is not 90. We would welcome 90 students. We get 200 to 300. And so the picture here on the bottom right, I don't know how well it shows up, but yeah, we have one classroom on campus really that can really do a good job with 300 students that isn't just like the stadium style seating. We have 3 instructors, myself, and I mentioned Jeff and Art, and then we get TAs kind of based on however many we get enrolled. And this is a 2-hour meeting time twice a week. And all of this is replacing a 1-hour, 1-credit seminar course that we said, this really isn't doing a lot for our students. And so some of you may be able to relate to that. I'm not throwing seminars under the bus, but when you start to talk about for a first year freshman, they may not really know and understand what civil engineering is, and just kind of talking at them for an hour a week is maybe not the most effective way to get them excited about what's coming in the rest of the curriculum. So we sat down and kind of outlined what do we want out of a first year course. And so I want to highlight a couple key ideas. First, well, we need them to know what a civil and environmental engineer is, right? That's what we were doing in our seminar. We want to keep that. But while we can't get into like technical like labs, we can't get into design, design of structures, or really get into environmental engineering, okay? We still want them to get something more out of this course. And so we kind of went through and said, okay, what do we want? We want assignments. We want them to start meeting deadlines and seeing what rigor is in an engineering course. Hey, how about some teamwork? Even at this large scale, I believe that teamwork can be done effectively. And we have been pushing in other parts of our curriculum to add teamwork elements. And so, again, if we can introduce it the first day, when we hit them again in the second year, third year, fourth year, they're going to see it there again. Then we wanted to introduce technical communication. If your students are anything like mine, They don't necessarily love writing. They came to engineering, and I've had many students tell me, I came to engineering so I didn't have to write. And we smile and say, too bad. And so we really do, again, we want to introduce this early so then we can start reinforcing it in other places later on in the curriculum. And then last one, and again, I'm going to steal what Armin did, is I'm going to pull this, we pulled this one straight out of ABET, so identify, formulate, and solve engineering problems, okay? So at the freshman level, okay, we can't get too complex, but we can get them into thinking about how to solve some problems. We're talking about project-based learning, so just highlighting some of those core tenets of project-based learning. We want challenging problems that are open-ended. We want sustained inquiry, so that we just want it to last and be substantial. It's not something you're going to accomplish in an afternoon or a week or things like that. We want some authenticity to the project so students can actually relate to it. We want some student buy-in, so this starts to speak to some of the motivation. Also, and sometimes what gets overlooked is providing opportunities for students to reflect on that learning and that process. And then finally, we want some critique, revision, and again, introduce that engineering cycle where you do something, you get some feedback, you fix it, and you keep going. Part of this, this whole revamp was sponsored by the Keene Family Foundation, or the Keene Network, which promotes this entrepreneurial mindset learning where they want to see in engineering education the 3 C's: curiosity, connections, and creating value. And so we kind of do all of this on that backdrop as well. All right, so let's get to the project itself. Students are tasked with going out and identifying a problem on campus. We do provide a short list of projects that either we're aware of, actually our facilities and services group will actually contact us and send us some projects and say, hey, we have this problem, can you all kind of think about some solutions? But in the end, what happens is the students really are pretty good once you get them primed and thinking this way, that they're finding problems. And so about 75% of them, 3/4 of them, these are student-identified things. And we really do allow anything, I say, in the civil and environmental engineering domain, plus. So what does that mean? We also let them get into energy, and things that are a little bit peripherally related. When they have identified a problem, then they have to propose a solution, and then they develop a feasibility study around that solution. Finally, they have to communicate their study, and that's where all the writing comes in. Now, here's my picture of the heated sidewalk again. And so why is all about heated sidewalks? You'll have to ask our students, because that is by far and away the project they pick most. This is not a project they are suggested. We never talk about it. But every year, our students think that in Champaign-Urbana, we have horrible snow conditions, and then we never clear the snow. So every year we get a group that is, we're going to melt the snow off all the sidewalks, which those of you who are not familiar with Champaign-Urbana, we get snow about 4 times a year, and it's usually gone within a week. So it is not a problem, but we don't tell the students this. We allow them to explore and discover this all by themselves. So as I said, we do scaffold this learning. So we don't just, kind of throw them to the wolves. We provide some case studies. This is where we can introduce what is civil and environmental engineering. So we have faculty present not, okay, what is structural engineering? We have them present a specific application And so we don't even really let them present their research. It is, maybe a consulting project they worked on, maybe some type of field visit, something like that, something that's really applied and students can relate to. Then we go through the technical writing. We call it sections of a report. And so we break reports down into the sections, what's needed, and here we start to actually also build in, okay, after you write it, now rewrite it, read it, revise it all over and over and over again, really emphasizing that writing is a process, not a linear start to finish type of operation. Then we have journaling. We call it journaling, but it's really just the project ideation time. And we start them small. We say, go to this place on campus, look at this specific problem, and start to come up with solutions to that problem. Last year, we sent all of the students to the main street on campus, where we had all the food delivery cars parking in the bike lanes, and they blocked the bike lanes, and then it also caused the regular traffic to have to cross into the other lane of traffic. And so it's a really unsafe situation all the way around. And so we had so many students out there like talking about it and stuff. Actually, the local news came out and did a couple interviews, and then the news said, hey, the campus is solving this problem. And we're like, well, it's not that big of a problem, and these are freshmen, but that's okay. So we give them some practice and then turn them loose to go find their own ideas. And then we, throughout the semester, are building in all sorts of other skills, so things like computation. How do you process data? So this is Excel exercises, things like that. Peer review. So I mentioned the revising your writing. Well, how about read your neighbor's paper and give them some feedback? We do teamwork, team contracts, peer evaluation as part of teamwork, and then, as I mentioned, this entrepreneurial mindset learning, where we're kind of reinforcing that language on being curious, making connections, and then creating value. We also get some other support from other groups because, again, we have 3 instructors. For last year, we had 300 students. We found that unless you are kind of actively engaged early, some of these projects can be very poorly scoped. One year we had a group make it through about half the semester where their project description was plant trees. That was it. They couldn't tell us where or why or anything, but because we were, very stretched thin, that one kind of slipped through the cracks. Whereas then another group might propose redoing the entirety of the Champaign Urbana road system, where, that's maybe admirable, but a little too ambitious for freshmen in their first year of engineering undergrad. And so we've brought in some external personnel. We have some research faculty. We have some campus administrators that actually have gotten involved. And they help to start coach and provide some feedback on projects. And then the thing that we've been using some external support for is this near-peer mentoring. We've actually started taking our senior level engineering course, and they are now the peer mentors for our first year course. And what's really neat is then it kind of bookends their educational experience, where they come in not knowing anything, and then by the time they leave, they get to come back to that, kind of see themselves in the freshmen and see, oh, wow, I actually have learned a lot. And we have a lot of really interesting findings out of the peer mentoring. So how do these projects go? I'm cherry picking some of the ones that are more interesting and successful. Some of these have ended up being built. The university has been in communication with us, and sometimes we come back and we say, hey, they had a really good idea about the project you proposed, and well, all of a sudden it gets built. And so that's the one in the middle, where this waste food to energy, where they are actually collecting waste food from the dorms, and they grind it, and they do some environmental stuff, and they get methane gas, I think it's methane, out of that digester. And this is now being implemented at all of our dorm buildings. The one on the left, we had I don't know if he got lost on registration day, but he was a CS student who wandered, computer science student, who ended up in our class. But he worked with a group that really wanted to do something with the buses, and so they actually went through the bus tracking software and mapped out long and short delays, and they mapped it to the signal timing of the traffic control signals, and actually came up with recommendations for redoing the signal controls to prioritize bus movement, so the buses would be able to move much freer on campus without causing other delays to pedestrians and cars and things like that. Maybe the most unique outcome of all these projects was this Deep Walk company. So this group, this was several years ago, this group started in our intro course. They really liked their idea. They actually got involved in some of the entrepreneurship centers on campus, and they've developed this now into a full they're selling this technology where they're scanning sidewalks for ADA compliance. And that's now, I was telling someone that they even had a booth at TRB this January. So what did the students say about this? And again, some of this, these are quotes that we pulled from some of their reflections. But in addition to, okay, so they're getting a lot of the stuff that we were setting out to do. So, hey, they're appreciating teamwork. They're appreciating the writing components. They're identifying what is a civil engineer, and they're getting excited about what's going to come in the future curriculum. Some of the other really cool things that don't show up here, but we've had a lot more students that get involved with undergraduate research or asking about undergraduate research at the first year level. I have 2 students that are here today, or actually they're flying home today, but out of this class they said we want to get involved in concrete. And so they've been involved in our concrete competitions at ACI now for several semesters. And so there's a much higher level of engagement with our first year students than what we've seen in the past. Okay? And so kind of big lessons learned. The more we emphasize that writing's a process, the less they take it personally when they realize that they're not a fantastic writer on the first day of class. And so they're more open to that iterative process that is writing. As I mentioned, advising these projects, it's a big task for 3 of us. So we brought in all of our seniors. They turned into advisors, and all of a sudden our project quality has really helped just getting that proper scope from the first couple of weeks. And then this peer mentoring in general has a whole bunch of other positive outcomes, especially in this large class. You're gonna have to wait. That's in another publication that's gonna be coming out shortly. Sadly, heated sidewalks are not feasible. I don't think they ever will be feasible. No matter how many students study it, they have studied it every single way. We're probably just never going to see them in Champaign. And so with that, I just want to acknowledge our Academy of Excellence for Engineering Education in our college, and then the Kern Family Foundation for some of their funding.